Alright, so today we're going to learn about the unit circle. And so in this section, you will be able to evaluate trig functions using the unit circle. You'll be able to determine domains of our trig functions as well as use trig identities. Alright, so with the unit circle, the word unit in math actually means one. So the unit circle is just a circle whose radius is 1. Alright, and so if you have like an XY plane, we typically put the center of our unit circle on the origin. And so then we would get this nice equation for our circle, x squared plus y squared equals 1, which should look familiar, looks like a Pythagorean, and we'll talk about how it's related to the Pythagorean theorem. Alright, so this is a little bit of review. So we've talked about this before. Using the definition of an angle in radians, we're able to figure out an arc length S. Alright, so remember theta is S over R, and if we multiply R on both sides, we get S equals R theta. But in a unit circle, the radian measure of the central angle is equal to the length of the subtended arc. Alright, so both are given by the real number t. So in a unit circle, our angle and our arc length are the same number. Alright, it's because of the radius being 1. Alright, so we could have a positive angle, you know, when we go around counterclockwise, we get a positive angle, or we can get a negative angle going around clockwise. Alright. So one thing to note is these are points around our unit circle are points on our xy plane. So we can have an x value and a y value. And so we can actually define our trig functions using the unit circle as well. Alright, so here are those definitions. I don't want you to focus too hard on these definitions because they're exactly the same as the ones that we learned with a right triangle, and I'll talk about why that's true. Okay, so we have our normal 6 trig functions, sine, cosine, tangent, and their reciprocals, cosecant, secant, and cotangent. Alright, so note that we see that sine of t is y, which is not exactly what we're used to. Alright, so let's talk about why these are the same. Alright, so we are right now talking about a unit circle. So I'm going to draw a unit circle on an xy plane off to the side here. I'll pretend like that's a good circle. Okay, and then I'm just going to draw an angle that leads out to some point x comma y. Alright, and so here's my angle in here. Alright, so as of now, we're only used to defining our trig functions using triangles. Well, we can actually make a triangle inside of here. This would be a right triangle, where this side length is defined by what's on the x-axis, right? So this is length x, and this side is defined by what's on the y-axis, right? This is the height of our function. Alright, so this is defined by y. And then, of course, the hypotenuse, what would that be? Well, it's the distance from the center to the edge of the circle. It should be our radius, which is 1 on a unit circle. So that way, when we define our trig functions, we can still use opposite, adjacent, hypotenuse, just like we've been using. So for example, let's say this is our angle, sine of our angle, I should have named this t, sine of our angle is opposite, which is y, over hypotenuse, which is 1. Alright, so that's how we get sine of t is y. We could do the same with cosine. Alright, cosine is adjacent, which is our x, over hypotenuse, which is 1. Alright, tangent is opposite over adjacent, so y over x. Alright, and we can just flip all of those to get the other 6. So something that I want to point out is that sine is y and cosine is x. So that tells us everything we need to know about points on our unit circle. So points along the unit circle are x comma y, which as we see above, x is cosine of our angle and y is sine of our angle. All right, and so this is the same thing as doing cosine theta comma sine theta. So that is how all of our points on our unit circle looks. Okay, let's do an example using these, because I think it'll be a little more clear once we use them. All right, so this next example says, suppose that the real number t corresponds to this point on the unit circle. All right, evaluate the 6 trig functions. All right, so we want to find sine of t when t corresponds to this point. So what does that mean? We have our unit circle. All right, this is our x value, this is our y value. So we're somewhere where both are negative, so we're over here, right? Maybe somewhere over here. So this would be the point, negative 2/3, negative root 5 over 3. All right, and so we're talking about this angle, T. All right, so a couple things we could do. We could draw a triangle up and use opposite, adjacent, and hypotenuse, or we can remember, oh, x is just cosine and y is just sine. So we can use these to figure out all of our trig functions. All right, so remember, sine is y, so sine of t is negative root 5 over 3. Cosine of t should be the x value. It should be negative 2 over 3. Tangent is y over x. All right, so y is negative root 5 over 3 over our x, which is negative 2 over 3. All right, and we can simplify this. All right, so this is the same thing as multiplying by the reciprocal instead of dividing. 3's are going to cancel, so will the negatives. We get root 5 over 2 as our tangent. And then how do we find the other 3? Well, they're just reciprocals of the first 3. All right, so secant of t should be the reciprocal of sine t, so negative 3 over root 5. I'm going to go ahead and rationalize my denominator. Okay, let me box these. All right, so then we can do secant. That is just the reciprocal of cosine, so negative 3 over 2. And then cotangent is the reciprocal of tangent. So we have tangent, we got root 5 over 2, so we could do 2 over root 5, rationalize that denominator. Root 5 over 5 is our cotangent.